Hello geometry students. I know I taught this lesson in class, but I said I would also make a video. So here's the same lesson that we went through in class for section 3.2, angles formed by parallel lines and transversals. Our objective is going to be to prove and use theorems about the angles formed by parallel lines and a transversal. So first of all, we're just going to warm up by identifying each of the different angle pairs that we have that we learned in section 3.1. So angles 1 and angle 3, if we look at them here in their positioning, we can tell that they are corresponding angles. Angles 3 and 6, if we look at their positioning, they're on opposite sides of the transversal, or alternate sides, and they're on the interior of our two lines, so they are alternate interior angles. Angles 4 and 5 are on alternate sides of the transversal, and they are on the exterior, so they are alternate exterior angles. And angles 6 and 7 are on the interior, and they're on the same side of the transversal, so same side interior. Now we have one postulate here, which is the corresponding angles postulate, and it says something about corresponding angles. It says if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So we see our diagram here. We have parallel lines P and Q, and then we have lots of sets of corresponding angles, 1 and 3, 5 and 7, 2 and 4, 6 and 8. And each of those pairs of corresponding angles is congruent according to this postulate. So we can use the corresponding angles postulate to find the measures of angles in a diagram such as this. So if we're looking for angle ECF, we have to find the angle that it is corresponding to, and it corresponds with this 70-degree angle here. So this 70-degree angle is congruent to angle ECF, so angle ECF is 70 degrees. Now to find the measure of angle DCE, that's this 5x here, well, this angle is congruent with this angle because they are corresponding angles. So we can say that 4x plus 22 is equal to 5x, and x equals 22. So the measure of the angle is 5 times 22, or 110 degrees. Remember, the postulates are statements that are accepted true without proof. So since the corresponding angles postulate is given, it can be used to prove our next three theorems. So the next three theorems are the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. So we can see here for alternate interior angles, if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So 1's congruent to 3 and 2's congruent to 4. This theorem here says if two parallel lines are cut by a transversal, alternate exterior angles are also congruent. 6 is congruent to 8, 5 is congruent to 7. And lastly, same side interior angles says if two parallel lines are cut by a transversal, then the angles that are on the same side in the interior are supplementary. So 1 plus 4 equals 180, and 2 plus 3 equals 180. So let's prove the alternate interior angles theorem. So we have our statements and our reasons. Now I'm going to start off with the fact that L is parallel to M, because that's given. If L is parallel to M, then I know that the corresponding angles are congruent by the corresponding angles postulate. So 2, angle 1 is congruent to angle 3. And that's because of the corresponding angles postulate, which says if two parallel lines are cut by a transversal, corresponding angles are congruent. But I also have a set of vertical angles here. So I am going to say that angle 2 is also congruent to angle 1 by the vertical angles theorem that says vertical angles are congruent. So if 2 is congruent to 1 and 1 is congruent to 3, then lastly we can say that means angle 2 is congruent to angle 3, and that is by the transitive property of congruence. So we end up with saying if two lines are parallel and they're cut by a transversal, the alternate interior angles 2 and 3 are congruent. So here's an example. We have two parallel lines. We can see by our markings here. And if I look at angle EDG, that's this guy here, I want to try to find its measure. I know that it is corresponding with this guy here, so I am going to say that if I change to the right thing, I am going to say that 2x minus 135 is equal to x minus 30. That'll give me x is equal to 105. And so the measure of angle EDG would be 105 minus 30, which is 75 degrees. Now the measure of angle BDG, that's this angle right in here that we're looking for. These two guys have to be supplementary because they are same side interior and the lines are parallel. So that means 2x minus 135 plus x is equal to 180. 3x minus 135 equals 180. That gives me 3x equals 315. And x turns out to be 105. So then the measure of angle BDG is equal to x, so it's 105. Okay, here's another example. We're going to have to use this diagram to find x and y. So we've got to see what kind of angle pairs we're dealing with here. The very first thing I notice is that these, oh my word, if I don't stop doing that. The very first thing I notice is that this angle right here and this angle right here are corresponding angles for our parallel lines M and N and our transversal Q. So corresponding angles are congruent by the corresponding angles postulate, so I can write 5x plus 5y is equal to 60. Now I'm trying to see if I have any other kinds of angle pairs. If we look at lines L and N, which are parallel, and I've got this angle here congruent to that angle there because they are alternate interior angles. If P is our transversal with L and N being parallel, and alternate interior angles are congruent as well. So 5x plus 4y equals 55. So if I solve this system of equations by subtracting, we end up with y is equal to 5. And if we plug that back in, we get 5x plus 25 equals 60. That would be 5x equals 35. And x turns out to be 7. So using what we know about the types of angle pairs that we were given in our parallel lines and our transversal, we can solve for two variables and not just one. Okay, so rewatch any parts of the video for full understanding. If you're watching on YouTube, feel free to leave questions in the comment section. Also, that Google Doc that I've been talking to you about, you know what to do. And the lesson quiz on the next slide is not going to be doing class, but you can have fun with it and practice your skills.